Hello friends and welcome to the another session. According to the kinetic theory of matter, even at normal equilibrium or normal temperature, due to the thermal state of the gas, its molecule execute translatory random motion. Since there is no force to stop the motion of gas molecules, it appears that the gas field in the container should escape out quickly. But this is the contrary our experience. Clashes explained it by suggesting the molecules of the gas have a finite size and during motion they collide with each other. The molecules of the gas having finite size and they are colliding with each other after short intervals. In this collision, both the magnitude and direction of their velocities changes. The molecules of a gas do not exert any force on each other. Therefore, between two successive collisions, they travel in a straight line. Here referred the red molecules and observe the red molecules. Initially they are having slow speed, but after collision the momentum will change and the path of that particle is a straight line and the path of particle changes on collision. Thus, if we observe the path of a single molecule of a gas, it will consist of a number of haphazardly motion or haphazardly arranged paths of different lengths. So that is the path is zigzag. Now the distance traveled by the molecule between two successive collisions is called mean free path. These paths are of different lengths. So here we are assuming and just observe the in that first slide there are a number of molecules, but here are few of molecules are there, and observe that initially this molecule having slow speed, but after that its speed is changes. Look here, consider this molecule after collision the direction will change, but the path is straight line and the motion of the particle is in zigzag path, and this is the distance traveled by the molecule after collision is a path of that molecule, and when we take the number of molecules they are colliding with each other and the path is taken, then average path is called as a mean free path. What is the collision? According to kinetic theory of gases, the molecules are finite size. Between two successive collisions, a molecule moves with a constant speed along a straight line. These collisions are known as molecular collision. And what is the free path? At a given temperature, the molecules suffer continuous collision with another. Between any two collisions, the molecule travels freely a certain distance in a straight line. This distance is known as a free path. Thus, the free path covered by a gas molecule between any two successive collisions, or what we say, the consecutive collisions in a straight line, is called the free path. and the direction of the molecule is changed after every collision. And then we are considering a number of collisions are there. So after a number of collisions, the total path appears, and that path is to be zigzag, and the free path is not constant as. So the path will changes. So a term mean free path is used and defined as the average distance traveled by the gas molecule between two successive collisions. So this is the mean free path. So a molecule here travel this side, collide with the another one, so the direction will change. So the first length is there L1. After that, this molecule is, this one is collide with this one, so the path will change L2. Here the length is maximum, but here the length is shorter than this one. But after collision, the direction will change, and we get the third like way. We get the number of collisions are there, so that the number of path will there. The path is different, but the path is in straight line, and the path is in zigzag mode. And when we take the, or here the B is the position of the molecule where we escaping from the container. So we take the average molecule length of the molecule after successive collision, and we take the average. So this line A to this point is a free path, this point to this point molecule is a free path, this molecule is collide with this one, so the change path will change, the line is in straight line, and this is the free path. And when we take the successive collision, matlab means after successive collision we take the average free path, and we get, and that is the mean free path. How we get the average mean free path? The average free path, average of these free path having the lengths over a long time interval is called mean free path. Thus, the average distance traveled by the molecule between two successive collisions is called the mean free path. This distance is assumed to be a travel with uniform speed. It is represented by lambda. And shows the hypothetical zigzag path for a molecule. Initially, let the particle be at A. It travels with a distance L1 and reaches to point B, where it suffers a collision with another molecule. In this collision, its speed and direction both changes. Now it travels in the direction of next collision, and after traveling it a distance L2 suffers next collision, and so on. Let the successive free path be L1, L2, L3 and so on. Then we take the mean free path, that is the represented by lambda, is equal to L1 plus L2 plus L3 plus up to L1 Ln divided by n. Here the capital L is the total distance traveled by the molecule, and n is the total number of collisions suffered by it in given time interval. At a room temperature, this is an example, at a room temperature an air molecule suffers about 4 into 10 to the power 9 collisions per second and travels a mean free path about 10 to the power minus 7 meter. When the gas is no equilibrium or not equilibrium, the random absurd motion of gas molecule gives rise to viscous, diffusion and conduction. So in this way the molecule transport their energy, their viscosity and their diffusion or conduction. So this phenomenon is known as a transport phenomenon. Later on we discuss on these transport phenomena. But initially, what is the main free path we are discussing? Now, how we get the expression? By individual considering the molecules. So that is the expression of mean free path. Suppose the molecules are identical and perfect elastic sphere, like the first slide or the second slide. They are having identical and perfectly elastic sphere. And let the number of molecules per unit volume of a gas. What is the meaning of number of molecules per unit volume of a gas? It is the molecular density, and that is the N. All the molecules are similar with a finite size. The number of molecules having diameter, and it is denoted by D. So here we are considering the single molecule. Likewise, the number of molecules are there. In this simplest model for demonstration or to determine the mean free path, we assume only one molecule here, and this line with the red line with the pink color is the effective collision area, that is A, and the value is pi d square. Now the molecule A is moving this direction, the molecule this is moving this direction, they collide with each other. When they collide, the sphere of influence is set up. What is the sphere of influence? In the kinetic theory for an ideal gas, the gas molecules are identical and perfectly elastic spheres moving randomly in all possible directions. In doing so, they are continuously colliding against each other. For the simplicity of calculation, it is assumed that the molecule under the consideration A is in motion, all other molecules are at rest. Let D is the diameter of each molecule, taking the center of molecule here, A as a center. If we draw the sphere of influence, or that is before the influence, it is the sphere of radius D, then molecule A will collide with all those molecules whose centers lie within the sphere. So this molecule lies within the sphere. Such sphere is called sphere of influence. अब समझो यहाँ पे क्या होता है कि ये मॉलिक्यूल रेस्ट पे है और ये मॉलिक्यूल इज इन मोशन. When they collide with each other within the sphere, this sphere is called as a sphere of influence. From this center to this point, that is the D. So we take the pi d square. From this figure, we can calculate the expression of mean free path. The two molecules will collide with other molecules, falls inside the sphere, as it is the sphere of influence of the molecule A. The sphere of influence molecule A will be sphere of diameter D. यहाँ से यहाँ तक का ये D होता है, पूरा ये D होता है, with as a center A. This motion molecule A is equivalent to the motion of sphere of diameter, that is the D. If the molecule is moving with velocity v, its sphere of influence in time t, describe a cylinder of length v like this way. ये सिलेंडर है उसका, and base, that is the pi d square. The volume of the cylinder will be, पूरे यहाँ से यहाँ तक का अब इक्वेशन क्या बनेगा, ये पाई डी स्क्वायर, ये क्या होता है एक्चुअली इस बेस पे और इस बेस पे होता है, यहाँ पे और यहाँ पे, और इसकी वेलोसिटी ये किस डायरेक्शन में जा रही है और इसका ये करस्पॉन्डिंग टाइम। सो ये इक्वेशन क्या होगा फिर इस सिलेंडर का, पाई डी स्क्वायर वी टी। द क्वांटिटी ऑफ पाई डी स्क्वायर हैज द डायमेंशंस of area and is called as the cross section. किसका cross section होता है ये, collision का cross section. So we can say that the collision cross section of molecule. It is clear that in time t this molecule will collide with all those molecules whose center fall in the cylinder. The number of molecules in the cylinder is pi d square vt into n. अब इसको भी हम इस पाई डी स्क्वायर वी टी इंटू एन को हम ये भी बोल सकते हैं कि द नंबर ऑफ मॉलिक्यूल्स कोलिजन्स suffered by the molecule A in time t. Therefore, the average distance traveled by the molecule between successive collision, that is the mean free path, ये सिलेंडर से हमें मिलता है। अब यहाँ पे क्या होता है देखो, ये जो सेंटर लोकेशन ऑफ टारगेटेड मॉलिक्यूल ये, ठीक है, अब ये हमारा पूरा सिलेंडर है और ये पूरा जो इसमें से जा रहा है तो ये होगा उसका मॉलिकुलर साइज। अब जिस डायरेक्शन में मूव हो रहा है उस डायरेक्शन की वेलोसिटी एंड टी ये लेंथ के हिसाब से, एंड द एनवी मॉलिक्यूल्स पर यूनिट वॉल्यूम। अब इस सिलेंडर का वॉल्यूम क्या होता है, पाई डी स्क्वायर वी टी, और इस मॉलिक्यूल का क्रॉस सेक्शन मॉलिकुलर साइज का एरिया होता है पाई डी स्क्वायर। ओके, so mean free path lambda is equal to total distance traveled in time t divided by number of collisions in time t. So the collision of molecular A in 1 second, that is the pi d square n, with the velocity in time t, and collision takes place in, जो इक्वेशन आएगा ये होगा लैम्बडा इज इक्वल टू ये टोटल डिस्टेंस ट्रैवल्ड सिलेंडर का वी टी, नंबर ऑफ कोलिजन्स कितने हो रहे हैं हमारे n टाइम्स हो रहे हैं तो उसका विथ वेलोसिटी एंड टाइम के साथ, सो पाई डी स्क्वायर। Then we rearrange it, so this equation becomes lambda is equal to vt get cancelled, so 1 divided by pi d square n. So in this deduction it is assumed that the moving molecules collide with the other molecules which is at rest, but this is not true. ये नहीं होता, ऐसा हो नहीं सकता क्योंकि मॉलिक्यूल्स ड्यू टू देयर थर्मल एनर्जाइजेशन दे आर वाइब्रेटिंग कंटिन्यूअसली एंड दे आर कोलाइडिंग विथ ईच अदर, so every molecules executing the motions. The Clashes and Boltzmann consider this assumption that all molecules are in motion with equal speeds, obtain the following expression, that is the mean free path of the gas molecule, that is the lambda is equal to 4 pi d square by 4 pi d square n. But this assumption is also not realistic, as all molecules do not move with the same speed. They move with different velocity in different direction. On the basis of velocity, that is given by the velocity distribution by Maxwell's, obtain the mean free path equation, that is the lambda is equal to square root divided by 1 divided by square root 2 pi d square n. This is the more correct formula for the mean free path of the gas molecule. If mass of each molecule is m and the number of molecules per unit volume is n, so the density of the gas will be mn. Rho is equal to mn. So we are just substituting in the equation this n की जगह पे हम ये रो बाय m रख देते हैं. तो इक्वेशन बनता है अपना हमारा लैम्बडा इज इक्वल टू m डिवाइडेड बाय अंडर रूट ऑफ 2 पाई d square into rho. For a given gas, the mean free path of molecule is inversely proportional to its density. Now in terms of temperature, what happens if you are increasing the temperature or decreasing the temperature? How we get the relation? The pressure of gas can be expressed as P is equal to PV is equal to RT. So we just rearranging P is equal to RT by V. Now RT is what? The number of gas molecules with temperature. So just we are taking the R is the number of gas molecules and representing the N divided by V, and T is the KT. So we get the NKT. That is the small NKT, not the capital N. So we get N is equal to, value is the P is equal to NKT. So N is equal to P by KT. ये इस इक्वेशन को हम सब्स्टिट्यूट करते हैं, मतलब फ्रॉम इक्वेशन 4 कंसिडर, मतलब जो ये इक्वेशन कंसिडर कर लेते हैं. दैट इज द सब्स्टिट्यूट कर रहा हूं मैं यहाँ पे लैम्बडा इज इक्वल टू 1 डिवाइडेड बाय रूट 2 पाई डी स्क्वायर पी बाय के टी. ये इक्वेशन कहाँ से लिया हमने? दैट इज द लैम्बडा इज इक्वल टू 1 डिवाइडेड बाय अंडर रूट 2 पाई डी स्क्वायर एन. नाउ क्या चेंज होता है इसमें? जस्ट वी आर टेकिंग द के टी गोज टू न्यूमरेटर साइड, सो के टी डिवाइडेड बाय अंडर रूट 2 पाई डी स्क्वायर इंटू पी. इसका मतलब क्या हो रहा है? द मीन फ्री पाथ ऑफ द मॉलिक्यूल ऑफ गैस इज डायरेक्टली प्रोपोर्शनल टू द एब्सोल्यूट टेम्परेचर, यहाँ पे एब्सोल्यूट टेम्परेचर and inversely proportional to the pressure. So this is the main free path. In next session we discuss the transport phenomena, and just we are validating the verification of lambda with temperature. So as we know the transport phenomena, according to the kinetic theory of gases, the molecule of gases are in the state of thermalization. That is a steady state or equilibrium state by transporting momentum, by transporting heat, that is the thermal energy, and by transporting the mass. And that transportation takes from one layer of gas to the another layer of gas. That changes or that gives to rise the viscosity, conductivity, and diffusion. Such phenomena is called transport phenomena, and the transport phenomena occurs only in the non-equilibrium state of gas, and all these are depends upon the how it transport, how it collide with each other, how the after collision they changes their momentum, how they changes their energy. So in first slide we observe that when the molecules, targeted molecules, are initially are in slow motion, but when they collide with each other, the abrupt change, that is the speed, will change and direction will be changed. So in that way they transport the energy, they transport the momentum, they transport the conductivity, and such viscosity, diffusion, and mass is referred as the transportation of the all phenomena. That is the transport of momentum, that is the viscosity, the transport of diffusion, then the transport of thermal energy, that is the thermal conductivity, and transport of diffusion is referred as the transport of mass. So this is the main free path. Thank you very much for observing or watching this video. Thank you.